Hi. So the name of the project is Predicting Wins of IPL Matches. So first we will import NumPy and Pandas. Then we will import our necessary data sets, which are matches and deliveries using pd.read and store them in match and delivery variable. Then using dot head we can see the top five rows of the match dataset. Here you can see different columns and all the details regarding the match between team 1 and team 2, which city it was held in and date. Then we just write its shape to understand what its dimensions are. Then again delivery.head to see the top 5 rows of the delivery dataset. And now we will calculate the total runs scored in each match and inning by grouping the delivery data frame by match ID and inning. Then reset the index of the resulting data frame, which is total score DF. The dot sum is used to summation all of the runs in the total runs column. Then we will further filter the total score DF data frame to keep the only the rows where the inning is equal to 1, which represents the first inning of each match. And here you can see the newly created total score DF data frame. It has match ID column, inning column, and total runs column. Then we will merge the match and total score TF data frame based on the matching columns ID from match and match ID from total score data frame. This operation is used to associate match data with total runs scored in the first inning of those matches. So here we can see the match DF data frame, which combines match information with total runs data. And we can see because of merging we are able to see the total runs column in this newly created match df. Moving on, we are getting the unique values of the team 1 column in the match df data frame, which is showing the different cricket teams that played. Furthermore, we created a new list named teams, which whose purpose was for updating the outdated names in the match DF data frame. So that is exactly what we did. We replaced the string uh, as from Delhi Daredevils to Delhi Capitals using str.replace in teams 1 column, and we did the same thing in the teams 2 column. So to standardize these names, these lines filter the match DF data frame to include only rows where team 1 and team 2 match the team specified in the team list using dot is in teams function. This filters the data frame to contain only matches between the specified teams, which ultimately standardize our match DF data frame. Using dot shape, we can see the shape of our data frame. Now here uh, we are filtering the match DF data frame to include only matches where DL is not applied. DL basically means Duckworth Levi's formula, uh, we, uh, which is indicated by 1 in where it is used and 0 in matches where it is not used. Then further, uh, we are creating a new data frame that consists of specific columns from match df, such as match id, city, winner, and total runs. This reduces data frame focus on the selected columns for further analysis. Now we are merging the match df data frame with the delivery data frame based on the match id uh, column. This combines the information from both data frames into a single data frame named delivery df, allowing us to work with match and delivery data together. Next, uh, we are filtering the delivery df to include only those rows where inning is equal to 2. This selects data related to the second inning of each match, and here you can see our newly created delivery underscore df the data frame, which only includes second innings and all the information related to it. Now we are creating some new columns to our delivery df. So the first one we are going to add is current score, which we are going to calculate using CumSum function. Uh, this function calculates the cumulative sum of total runs y within each match. Total runs y contains the runs scored in each delivery. Then the next column, runs left. This is calculated by uh, by subtracting the current score from the total runs, which is the target score needed. And now the third column and the last column which we are going to add is balls left, which we are calculating the number of balls left to be bowled in the match. We start with a total of 126 balls, 21 overs including the zeroth over, and you subtract the number of balls already bowled based on the over and balls column. So then we can visualize our modified delivery data frame, and if we just scroll it here we can see the create newly created columns which are current score, runs left and balls left. Now, this code snippet basically handles the data related to player dismissal. If player dismissed column is empty, the value in it is empty, uh, or NA, it is filled with 0. Then we convert it to binary representation 1 if a player was dismissed, meaning it had some already existing value, then that particular value will be converted to 1 and the entire column type will be converted to int. On the second half, uh, we are calculating the number of wickets lost for each match. The CumSum function calculates the cumulative sum of player dismissal and we subtract it from 10 to get the remaining wickets. And let us see how our new delivery df looks like using dot head. And as we can see, the player dismissal column has zeros and ones as values, though you can't here see one, but there is definitely in the rest of the rows. Next we are going to add few columns to our data frame, namely CRR, which is current run rate, that is calculated by dividing the current score by the remaining balls, and required run rate RRR uh, by dividing the required runs left to win by the remaining balls. Then we are going to define a function to determine the match result. This line function result is defined where the function checks whether the batting team is the same as the winner of the match. If they are same, the function returns 1 indicating a win, otherwise it returns 0. Moving ahead, this code snippet applies the result function to create the result column. using dot apply. Then we are going to create a final data frame which will have all of the necessary columns which we are going to need for our model from delivery DF. We have selected all of these columns which are batting team, bowling team, city, runs left, balls left wicket, total runs X, CRR, RR, and result. Then we are going to randomly shuffle the rows of final DF using this line, and uh, we are going to just pick a random sample from it and see how it looks like. So one of the rows, uh, it has Delhi Daredevils as batting team, bowling team, city, runs left, and so on. Then using dot drop NA basically removes the rows with missing values. Then uh, this line removes the rows where balls left is 0, meaning those won't be useful in our model training. And finally, we are going to create our x and y variables for our training and testing. Our x variable contains all of the columns except for the last one, and y contains only the final column, which is considered to be the target variable, which is result, as we can see here. Then we are going to import train test split from sklearn, and splitting our x training and testing, such as only 20% is for training testing, and 80% the rest of it is for training, and random state is set to 1. Here we can see how our x train looks like. It has all of the feature columns except for the result, and if we actually do this same for y, we will see only the final column. Then we are going to input column transformer and burnout encoder from xklearn, and trf, which is transform function, uh, where we are going to use the column transformer on batting team, bowling team, and city columns, where we are going to drop the first category. And as we wrote here, a remainder is equal to pass through, which means the rest of the columns are numerical columns which will be going in untouched. There is no need to transform them as they are numerical. We can just see here, runs left, balls left, those columns contains numerical values, so no need to transform them. Then we are going to apply logistical regression for model prediction, so we are going to import it. We can also solve this problem using random forest, that why I wrote it here, but there is no need. Then we are going to import pipeline, and this pipeline will be stored in pipe variable, which has step 1, it will use column transformer on our columns, and step 2, it will use logistical regression with solver as live linear. Then we are going to fit this training pipeline into our x train and y train for training our data, and then use this trained model on test data x test to predict and store it in ypred. Then we are going to import accuracy score from sklearn and test our accuracy on y test and ypred. It will going to compare those, and the predicted value is 0.80, so it is 80% accurate. Then we are just going to predict a random 10th sample, 10th index of the X test data, and we can see how the actual output looks like when we use our model. Here, the first element 0.167 indicates the probability of the team 1 winning, and 0.83 indicates the probability of team 2 winning. So when we actually see those, it seems that team 2 has higher probability, which is 83%, it is going to win. And since we are using logistical regression, it will be tending towards 1. So yeah, and then we are going to uh, put additional functions for just better clarity and for better understanding. So the first one is match summary. Here we are using this function to understand what the current batting team is and bowling team, and what is the target total runs required is for any ongoing match. Then, well, not ongoing, but depending on what match it is or whatever the row we want to see the summary of. Then we are going to create another uh, function, which is match progression. This section basically defines another custom function, match progression, which provides a detailed analysis of cricket match progression. It takes three inputs: XDF, uh, then uh, match ID, and pipe, the trained model. The function selects data for the specified match and processes it, calculating various match statistics. It calculates the records, the probability, and records the probability of winning and losing the match at each over. It also tracks the number of wickets taken and runs scored during each match, and the match's target score and the progression of match and wickets are printed using print target. And that is how basically this entire function works. Then uh, we the match progression function is applied to the delivery data frame for a specific match with match id as 74. The resulting data and target score are stored in temp df and target respectively. And when we write temp df, we can see the match progression, how it's going. So end of the over, so the first end of the over runs after cover over, so four runs were done after the first over. Wickets in that over, lose chances and winning chances. This data can be represented in a graphical form. So we are using matplotlib to plot a line plot where the width is 18 units and height is 8 units of our plot, and end of the over is our x-axis, and y-axis changes as it's a line plot. So the yellow line indicates wickets in that over, green line indicates the probability of winning, and uh, red line indicates the probability of losing. And as a note, these winning and losing probabilities and the wickets uh, are for the batting team only, and it shows how those probabilities changes. Then we just wrote teams for better understanding what teams were involved in the IPL match. Then unique cities where the matches were held, and then using pickle we are going to save our model, and not and you we don't have to train that model again and again every time we want to use it. Thank you.